Okay, so where I left off, I was part of the way through some of this to-dos up here. I'm going to just sort out real quick what it was that I was working on, since it's the beginning of a new stream and a new video. So, this is the RPG simulator. The main thing I am doing right now, these three things, are getting it to a point where... wait, is it two or three things? Again, about cleaning up prototype. Nah, this is separate. These two, though, are the prerequisites for getting to a point where I can play with a plugin architecture in the simulator. So I'll be able to hopefully uh, use the RPG simulator as the test case, as the real world example of a program that's loading in DLLs that contain new code to extend the game or the simulation or the program or whatever. And so these are the two steps. First, I want to build out this module concept because a big part of what code would live separate from a big part of the code that would want to live separate from the main executable in my current examples is also tied in with this concept that I was calling module and now state. Either way, the point being, it's a piece of code that describes sort of the flow of the game with the main turn order logic is what the structure looks like and how the competition gets decided. So once I've got that up and running, I have the right tool in the language of the simulator to actually express separate concepts, and then splitting something out into a DLL will be completely real. It'll be like it would be if I was actually trying to design something like this that had plugin architecture. And that will make it an ideal test case for actually testing out if my base layer can handle being inside a program that has a main module and plugin modules. Or even multiple modules that aren't plugins, but just that are dynamically reloaded separately or something, right? Anytime you want to do anything that is DLL at the low level on Windows, what I'm going to call that is module or library, which is the level above that abstractly, so that it can work on any operating system, right? It's abstracted in a base layer somewhere. So something like a module library type system. Now I think where I left off is I had made some important changes. I don't know if I can remember exactly what they were, but probably I set up the new state script system. Yep, start, step, and exit. Begin, step, or enter, step, exit. Perfect. So that's the combat rule. And did I do the same thing for chase? It looks like Chase hasn't actually been transformed yet, which is interesting. I thought that Chase was transformed into a similar structure. I guess not. Maybe I had... Right, so I had manually written the logic that flows between the two, but I haven't actually written one that's based on these states being bound up and abstracted properly. So it was just hard-coded the flow between these two states. Now we're doing this. So yeah, I guess in theory, the next step here is it should be trying to transition to the chase state, and maybe that's just why it's busted, is something invalid is happening there. So I'm going to go track that down in Remedy real quick. Okay. Okay. But why is there a null target in the first place? We're going to need to look at hits gather begin, hits release, hit. There, how did that happen? The enemy party's already empty. Okay. Okay. So I think that's a good spot to catch the mistake, because it does make sense that in a script you might want to write code where occasionally you'll get a nil handle or a null handle like this one and just pass it through without checking. And so this needs to do the check. That makes sense. Okay. And then the question is, how are we going to figure out? So we're getting to a point where combat is running and the enemy party is already empty. So it should have been end of combat already. Okay, I think the best way to do this is going to be right here. Check for Check for party KO. And so this is going to need something to do like transition state, but it might need to get more complicated than that. I might need to be able to say that the transition state here might need to be able to include like I might want to have the transition state encode something about which party won or something like that. So this might become something like or something like that, but it's a little hard to say. Like, it'd be more complicated than just this, right? I'd have to check which party won, and if they both lost, I'd still need something else. So, I don't know. Exactly which transitions I want there are unclear. Now, what happens if one of these gets a null state? Does it notice and avoid the issue? No. There we go. So we get, okay, we're missing the end of combat. Now we can log this a little differently. Instead of putting okay, so now what I can do is I can call the combat log function from down here. So when we are going to finish the log on combat exit, before we do decrease the indent, let's grab this. Why is this way down here? Just put that right there. Maybe I should log before I free the combat context. Ooh, what happened here? They knocked out one of the mushrooms, and did 3 damage to this one right away. So 2 of them went to sleep. These must have been waking these guys up. But Buffer, hello, welcome. Yeah, this visualization's okay, but I'm missing the moves. I'm missing the ability to see what moves got made. This is the information about the states of the parties, but I also want to see like how were all the moves created so that I can be sure that like what must have happened here is 2 of them got put to sleep. If these 2 weren't both spending their time waking up these guys, well, it looks like they must have both attacked instead of using wake up. But here somebody did a wake up while someone did an attack. And why is that? Why did these 2 attack instead of doing wake up on round 1? It's a little unclear to me. Well, thanks for saying that, Buffer. That's very nice of you to say. All right. So, anyways, the log looks good again. It's got everything that it used to have at least. So now let's try to write a chase state script. And see if we can transition into the chase from combat somehow. So first let me grab the combat just outline, the outline of this stuff. So there's combat, or the enter, the step, now why is it doing that? I wouldn't be able to tell you. That is strange, the extra if there. It looks like it's doing something like this. I'm gonna just copy the boilerplate so that I have a good chance of it working, and I'll undo all of it together later as I untangle the map of who's responsible for what. But apparently, you gotta double check that you're actually accessing the right thing. Because we do grab the state data, which is a void pointer, so we're probably just thinking of that like check for the type, but we don't actually need to be doing that. So we'll see. Here I'm going to do RPG state decal chase so that we can see the chase state from down here. I feel like I want to change this structure just a little bit. It makes me uncomfortable having something that looks like it ends the current state in the middle of the function, even though it keeps going. What it's really trying to say is, like, we're going to peek and see. Okay, so that's roughly what we want. I mean, this could get more complex. This could all be transition states that I don't know about yet. For now, those will just be ends. But if we have a flee, if we have a transition into the chase state, we actually will encode that properly. So that's cool, but but I don't have anything that actually causes a flee to happen yet, right? So the way to flee is one of the parties has to choose to flee, and I don't have a move that can do that, and I don't have a brain script that can do that. So now, in order to get from there to there, I'm going to need that move to happen, and then I'll be able to start seeing this stuff execute. And then I can transfer the code from here up to there. Those are the steps. So maybe I'll just start with at least transferring. These can go away. These can go away. And then I can log this. And let's see what other boilerplate is there. We want 2 children. We want to swap out combat for chase. Taylor, yeah, I did work on the meta desk. I think the parser might not have been much me. I worked on the expression parser. I worked on, I mean, I definitely helped with getting some of the parser phrasing at certain points and the error message system and stuff figured out. I did a lot more work on things like the documentation and examples and making sure the data structures were tidied up and stuff like that. But I can't really remember how much I did on any given part. And yeah, I think after we got it out, initially Ryan kept working on it more than I did, and he's definitely I've didn't know this until recently, but he definitely got at least one variant version where maybe he did your sort of thing, where he takes the library and completely absorbs it into the code base. Because I know the RAD debugger has a version of Metadesk in it too that has been changed, and it may or may not be similar to the one in his private repository, so I don't know about that. Yeah, that's not surprising. Metadesk H and C might they're definitely built more with the like reuse in mind rather than example, so there's a lot of extra weight on them just to make them a little more reusable, and if you're going to consume them, then there's plenty you can burn off. That's all good. See you later. Okay. I mean, I've pretty much got it. I think I might as well just finish the transition to having all of this. Nice. Okay. Still nothing's happening because I'm just getting it to build with the state script instead of with these functions. But now what needs to happen is I need to see a transition from combat to the chase state by introducing a move that will allow you to set your flee flag for the combat context. So that'll look something like this. Okay, I'm thinking this through, and I feel like I want to experiment with one of two ways I could structure this part. Like I want to experiment with two different ways I could structure this part and figure out which one of them feels more like the right direction. The fast path to making something like this work would be to set up the flee tile as it is, and then say give put in a rule. So when we are gathering top moves here, we'll set up a rule that says give the flee move to everybody, right? So there's already this idea that we're going to gather moves, and so we could just give each character a flee tile. Now, the issue is, while that's possible, we're kind of going to then collapse the flee move down to a decision for the whole party. So if any character does, and this is how RPGs tend to be structured anyways, right? If one character in the party says flee, but you can decide something else for, like, that's usually enough to get the whole party to flee. It's not like you have to get each character independently to make that decision. But in this game, moves are made simultaneously, so all the characters are picking their move, which means one character in your party you can say flee with, and another character in your party you might say something else. And only those things that are actually going to affect the fleeing are going to apply, because we're not going to apply hits, and so attack style moves aren't going to work. They're just going to get ignored. But then weirdly, moves that you choose that are instantaneous will still apply. And that might be what we want, but I'm a little bit well, hey Viper Gamings. Yeah, I'm having a great day. Hope you are too. The other way I could think about it is there might be more like a sequence of decisions that goes first. You decide if the whole party is going to fight or flee, and if the whole party fights, then they get their moves here and they choose moves. But if they flee, then we can skip that. So combat would then be first step is decide whether you're fighting or fleeing. Both parties decide simultaneously. And then what we've got here, calculating the move set, giving moves, characters make their moves. This is what would happen if both parties chose to fight. and then all this flee related stuff would actually be pulled out and handled in the outer decision, right? But that also has a couple of weird, that changes things a little bit for the system. That means that now there are two decisions to make for the brains, or for each party during a combat round. The first is we would have to do something like how would this work? Clear the moves for each party. So we would give each party a move for fight and a move for flee. How's the project coming along? Pretty well, I think. This project, at least, has been very interesting so far. So like this seems okay, but there's a lot of stuff missing for making this reality. So like if this were how I were gonna dole out specific moves to each party, a fixed move set to each party, I somehow want to encode which combinations of moves are possible. The way that works with these is that we have action and quick action counters on each character, and each character gets one of each. So, like, I could just reuse these counters, right? I could say give moves, and here we'll give each party an action. I don't know if this will still be relevant, But this also invents this concept of sticking tiles onto a party, which I haven't done yet. And then parties make their moves. No hits. So here are some things this brings up, though. This is a cool system in theory. Um, the issue, though, is if this is how it works, then the flow for the player, if I ever make an interface for a human player, is going to mean that in each round of combat, these really are separate decisions. Because anywhere it says run brain, that's like one interface interaction. And so what actually wants to happen here is I want to decide between, like, I want an interface that looks like a big flee button for the whole party, or the ability to choose moves simultaneously displayed, right? There's like all the basic separate moves, and if you start doing those, then you can't flee. Or you can just decide to hit flee, but you don't have to hit fight and then fill out your decisions in the like most ideal version of the interface, right? You don't need to have every round of combat be two interface interactions that are separated if you wanted to make it smooth. So it makes me wonder how I want to adjust. I could, for instance, say with the flee move, gather from tiles and then throw a flee move onto each party as well. And then I need a rule about when you can do a full party move versus a separate character move that excludes doing both, right? It's like if the party does flee, then each of the individual characters can't also do the other thing. So how would I enforce that? I mean, it could be that the flee requires an action from every character. in the party. Um, Another thing that I'm thinking about here, though, is the current data structure for a move is that it's a doer what is a move? Tile proto, a doer, and a target. All right, that's what makes up one move. Let's write it like this. And doer and target are both assumed to be character entities. Okay. Now, one thing that sucks about this is it does preclude the idea of having moves that simultaneously involve multiple characters. Like if you wanted to make an RPG about a party of characters with synergistic moves, with you know, like cooperative moves between the characters, you wouldn't be able to do that here because there's only one doer and it's always a character. Now the question is how would I go about changing that? I could say that this needs to get replaced with a list of characters. And I suppose this can always be an entity right now. And of course, we have the option to make that come from a party. Or it can just be some other subset of that list, right? Like I could just want to say these two characters have a move together or something. Then, whenever you want to use it, the rule would be whatever kind of move this tile proto marks itself as, if it's an action, for instance, then all of the characters in this list need to have an action available, and when they use this move, all of them will decrement their action counter. Okay. Okay. That seems doable. It's a big step, but it does generalize things a little more nicely than what I've got. What I could do then is say, whenever we're adding a move, right now we're just passing a doer entity. We're going to want to have a couple ways of passing a list of sim entities because, well, we do have list entities already. But sometimes we're also going to want the ability to just have a character stand for a list of itself, right? So I can just pass in one character. So I'm gonna make that a optional way of doing things. And so all right, so here, if you get something other than a character, you just iterate down, and we're looking for characters. But add moveset, add character doer, moveset, add list doer. So that grows out in this direction. Doer, target. Okay, if we find a list or a party, then we're gonna do move push with the doer being the doer itself, right? That's the list or the party is now gonna get stored. Move push does give back the move, so I'm gonna grab the move and set the doer is list to true. Now, if it's anything other than a list or party, I guess we could still have a character check here. So if we call this accidentally passing out a character, we'll just do it like it's a character. But if you give me anything else, I'll recurse down, hoping to find one of these. And these are character doer, list doer. Okay, so I didn't break anything. But in theory now, the party has this flee tile available to it. I don't know. It doesn't quite fit. There's a couple things that don't quite work right here. Um, I'm thinking about what happens if a character in the party doesn't have an action because they're, for instance, asleep. If they're asleep, then there's always a character in the, like, when you're asleep, there's a character who doesn't have an action. And so the rule I stated is that every character has to have an action available so you can use it to flee. And it would make sense that if one of the characters is asleep and you can't split the party, then you can't flee. But what if you wanted to then implement a rule that's like, or a move, or a concept of one character being able to carry another, right? I think the idea that if one of the characters is asleep, you can't flee unless you have another solution of how to move them. But that's not represented here very correctly. I mean, like, okay, this actually makes sense that I would want, like, if I have... Hmm. I think the only way to grapple with this is going to be to draw it. Okay. So, as in terms of gosh, I can't control my handwriting at all. Okay, let me try better. Okay, so there the round begins. And now single party perspective. Okay. You might make one decision, which is to fight. Or you make the decision to flee. Then did enemy also fight? Question mark. Yes. Combat moves. Combat resolve. I mean, this is basically the way I think about the decisions. What's weird is that here, 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 and here, we have move set decisions based on those move sets generated by tiles off the characters. Here, though, here we have just, I don't know what you call this, like a fixed decision or a static decision. Maybe the mistake here isn't. Tile generated move sets. Here we have state generated move sets. Seven Artists, I don't know. I've never used it. It doesn't sound pleasant from a lot of the experiences I've heard other people tell me about, like what you're saying. The question's about Vulkan, and I haven't used it, but I've heard the fact that it's a great pain to get your hand around the whole thing. Like it's just sounds like it's a lot of pieces. All right, my penmanship didn't degrade too terribly. This is a little rough, but I think we'll get by with that. So I feel like a part of the reason why these want a split is because, first of all, the flow of when you move into these other types of moves scenarios is actually fairly complex. So you end up deciding on your flee moves after you've chosen to flee, before you see what your opponents are going to do in this particular diagram. And that's, I think, important for the storytelling here. The consequence of choosing to flee is that you commit to doing, going all out. Like, you might spend a one-time use, you might spend a mana, you might spend an item, whatever, to make sure the flee succeeds when you don't actually know that your opponents are going to use any chase moves. You kind of lock in the fact that you're fleeing up front, and then they see that you're fleeing and decide if they're going to chase or not. Right? So there is an advantage there. Now, if the other side also flees, but they don't put as much work into it, then you'll just exit combat. If the other side tries to chase, but you get away, you exit combat. If the other side tries to chase, but they overtake you, then you'll go back here, and this will have to get eliminated. If they don't overtake you, but you don't get away, then you come back here, and you can either keep fleeing or you can fight, right? So I think this whole thing should be a cycle like this. And the issue is, this is great for a single party, but there are actually two parties in existence moving through the flowchart, and maybe that's why it gets confusing. So they're both here at the beginning of combat. Let me pick a new color here. Okay, so we're going to start right here. Each party sees this decision. This would mean that I am going to give an interface that lets you pick one or the other before you do anything else. Right? Because I don't necessarily want to force you to lock in combat moves when the other side is fleeing. Right? I only want you to see combat moves if you first fight. So I think that this logic for the story works, and then that just means I'm going to end up having you choose to fight or flee. And this might also extend later, you know, and this is the beginning of an encounter. There might be other allowable moves and paths through the state diagram here. Okay. This makes me also wonder about investigating what happens when I look at two parties flowing through this together. So say the player chooses fight, so they flow down this path. Here, give me my pen back. And let's say the enemy is going to choose the flee path. So they're going to go this way automatically, while purple hangs out over here, making flee moves. And while green hangs out here, making chase moves. I see. These two are special because they are joins of two different flows, right? Green is flowing through and purple is flowing through, but green and purple have to meet on the other side. So you get this. Makes me wonder if I just need to use more states or something. Yeah, I'm seeing a whole nother level of thought that needs to go into this now. This is going to start getting um, different. I might say, okay, it's been a short early stream here, but I'm seeing a massive idea that I might need some time to play with before I can actually get back to coding. So this might just be a brainstorm day, but I also am getting close to lunchtime, and I think that maybe this would be better to do on a full stomach with a little bit more open-ended time for me to sit here and doodle and think. What I think is coming together here is that it looks like these are, give me a color that I can use. Okay. So this thing is clearly a state. Right now, this is flow logic. This is a decision, flow logic decision here. So at each state, decisions get made by a player. There's a green player here and a purple player. The green player and the purple player and are first bound in this state. They each make a decision symmetrically. Green flows through this way. Purple flows through this way. So purple visits this state by itself. This is a state. And at each state, decisions get made by one or multiple players. So here are decisions being made by purple. Here are decisions being made by green. Since they're in different states, they're in totally different times. They can be resolved independently in theory. Although I think we might also want to say that this will have visibility into this somehow. So when we say, did the enemy also fight? It'll say no, and so now we're waiting for them to make their flee moves, and then we can see what moves they're making. So the chaser gets the advantage of being able to see how the flee moves are being executed and decide whether or not it makes strategic sense to chase or to let them get away. Then, whatever set of moves they make, including the move to let them get away by doing nothing and saving energy, after this decision gets submitted, then a check happens, and so it flows here, and so the two then have to have somehow be bound together into a new final state. Or this isn't even a state here, this is a computation. It's all of the information gathered up from this set of moves and all the information gathered up from this set of moves get thrown together in here. If they'd both gone through combat, they'd go green and purple this way, green and purple this way. There'd be a green and purple set of moves coming in here, and this becomes a resolve. So really, all of this is the resolve computation for this state, and it involves more decisions. And then these here, here, and here are all states, right? And so yeah, somehow I'm going to want to be able to create a data structure that has the ability to represent this kind of state, this kind of state, and this kind of state, and map out the flow of information through all of this properly. If I can figure out that data structure, then maybe I can code each of these as one of my states, and so it'll get a little more complex than I thought. But it'll be more flexibly able to handle the kinds of flows that I'm thinking of without having to like code up. Right now I'm having to go like, did player 1 do a flee, then do this? If player 2 do a flee, then do that. If they both did a flee, then do this. I'm having to do the logic in more complex ways. I think if it could be decomposed into a flow for the perspective of one party and then put both parties on there as a way of tracking the states, then I might be able to figure out the set of total states from the set of from walking the set of partial states that are made this way or something, right? So anyway, I think, like I said, this might be a good time for me to, it's a little early, but I'll just stop and have lunch now, and I'll come back in an hour or two for a little bit more today of this kind of thinking. All right? So I will see y'all in a little bit.